What's up, guys? Today, we're going to see how exponential functions can be seen as infinite series using a really clever argument by Leonhard Euler in his famous textbook Introduction to Analysis of the Infinite. So, let's get right to it. We begin with the fact that any number a to the 0th power is equal to 1. It doesn't seem like this will tell us much about the relationship between exponential functions and infinite polynomials, but let's see where Euler takes us. He then says, if we raise a to an exponent just ever so slightly greater than 0, an infinitesimally small number we'll call omega, it should be equal to a number ever so slightly bigger than 1. So it'll equal 1 plus psi, a number which is also infinitesimally small. Then we'll just relate psi and omega by saying psi equals k times omega, where k is some number. So we have a to the omega is 1 plus k times omega. There's something very special about the right side of the equation, and it has to do with the binomial theorem, which shows the expansion of 1 plus x to the n. Euler noticed it, and he says to raise both sides of the equation to the power j. But what's j? He says let j be some number x divided by omega. Since omega is infinitesimally small, j is extremely large, just about infinite. So we raise both sides of the equation to the j power, and since we know j is x over omega, the omegas cancel out, and we get a to the x equals 1 plus k omega to the j. And since j equals x over omega, omega equals x over j. And we get a to the x equals 1 plus kx over j to the j. Now's the time that we apply the binomial theorem. The binomial theorem states that x plus y to the n equals x to the n plus n over 1 times x to the n minus 1 times y plus n times n minus 1 over 1 times 2 times x to the n minus 2 times y squared, all the way till you get plus y to the n. Therefore, 1 plus x to the n equals 1 plus n over 1 times x plus n times n minus 1 over 1 times 2 times x squared, all the way to x to the n. But we're raising 1 plus kx over j to the j power, where j is infinitely large. That makes this series have infinite terms because the power is infinite. So we get a to the x equals 1 plus j over 1 times kx over j plus j times j minus 1 over 1 times 2 times kx over j squared plus j times j minus 1 times j minus 2 over 1 times 2 times 3 times kx over j cubed, and so on forever. If we bring the j from kx over j to the denominator, we get the ratios j over j, j minus 1 over j, j minus 2 over j, and so on. As j goes to infinity, it becomes so large that these ratios all approach 1. So all of the j's cancel out with each other, leaving us with a to the x equals 1 plus kx over 1 plus kx squared over 1 times 2 plus kx cubed over 1 times 2 times 3 plus kx to the 4th over 1 times 2 times 3 times 4, and so on forever. So every exponential function can be written as an infinite series in this form. Just one problem. What's k? For most numbers, k will actually be quite complicated, but when will k equal something like 1? What number to the x equals 1 plus x over 1 plus x squared over 1 times 2 plus x cubed over 1 times 2 times 3, and so on? To get this, we have to go right back to the beginning. We set a to the omega equal to 1 plus omega because k is 1. To get a by itself, we raise both sides to the 1 over omega power. So a equals 1 plus omega to the 1 over omega. If omega is infinitely small, 1 over omega is infinitely large, which we call n. So omega equals 1 over n, and we substitute this in. A equals 1 plus 1 over n to the n as n approaches infinity. Now, once again, we employ the binomial theorem and get 1 plus 1 over n to the n equals 1 plus n over 1 times 1 over n plus n times n minus 1 over 1 times 2 times 1 over n squared, and so on. And since n is infinitely large, the ratios like n times n minus 1 over n squared go to 1. And we get 1 plus 1 over n to the n equals 1 plus 1 over 1 plus 1 over 1 times 2 plus 1 over 1 times 2 times 3, and so on forever. And this comes out to be a very famous number, which is just about 2.7182, which is called E, or Euler's number. And Euler's number is the sum of the reciprocal factorial numbers, as you can see here. This means that e to the x equals 1 plus x over 1 plus x squared over 1 times 2 plus x cubed over 1 times 2 times 3, which can also be read as 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial, and so on. So, I hope you've learned something new, and I encourage everyone to try to explore more properties about this on your own. Or even read Euler's book. There's so many incredible things in it, and it'll hopefully bring you a lot of joy. Now, get lost.